Hey everyone, Morgan here. So let's continue on to page 2 of the electrochemistry outline. And when we finish page 1, I just introduced this term oxidation number. So what's an oxidation number? It is the imaginary charge an atom would have if the shared electrons were divided equally between identical atoms bonded covalently to each other. I've been teaching chemistry for over 30 years and I'm still not sure I understand what that means. Any definition that starts out with the word imaginary bothers me. Okay? Oxidation numbers are a way of keeping track of how many electrons have added or left a specific species. Okay? So we have some rules for assigning them. The first rule is for an atom in its natural state, the oxidation number is 0. Basically meaning it has no charge. So if I say I've got some zinc metal, Zn, it's not charged. Its oxidation number is 0. Rule 2, for a monoatomic ion, the number is the charge, which means they can be both positive and negative. Number 3, oxygen is always -2 except natural state and in peroxides it is -1. So oxygen in its natural state has an oxidation number of 0. That's rule number 1. Most of the time it's a -2. There are some rare exceptions, these things called peroxides, where it is -1. You will not use that many peroxides in this class, just some of hydrogen peroxide, the same stuff that you'd find at home in the bathroom. Rule 4, hydrogen is always +1 except natural state and in metallic hydrides, where it's a -1. And hydride was one of those polyatomic ions in your list, the same way peroxide was. H2, natural state for hydrogen, 0. In compounds, it's a +1. Very rare exceptions, it's a -1. And then the last rule is for a polyatomic ion, the oxidation numbers must add up to equal the charge. Okay, so rules are funky things sometimes. Examples are much better. Let's focus on bromine. Br- monatomic ion, -1 charge, oxidation number is -1. BrO- or OBr-, you can write it either way. We know that oxygen's a -2. That tells me the bromine must be a +1. +1 and the -2 add up to be -1. Here I've got 2 oxygens, so I'll go -2, -2. The overall charge is a -1. That bromine must be a +3. +3 with those couple of -2s equals a -1. 3 -2s because I got 3 oxygens. Hopefully what you're starting to see here is that an oxidation number is assigned to an individual atom, not to a compound. So that means this bromine must be a +5. Okay. I think following that pattern, you can recognize that one's a +7. Br2, that's its natural state, so it's going to have an oxidation number of 0. If it didn't, it would have a charge showing. Na, sodium's a +1. It's in group 1 on the periodic table. That means this bromine's a -1. KBRO, if you look carefully, you realize that's just BRO minus. So the bromine in there we've already shown to be a +1. All right. Thanks for tuning in. This is Morgan, signing off.